AP Chemistry Screencast 2.4 Mol-to-mol and mol-to-gram conversions. Let's take a look at what happens in terms of moles and grams when we're converting it. We're not going to cover gram-to-gram conversions. That'll be a separate slide. So just imagine that you're burning some butane. We've got a balanced chemical equation already laid out for you here. And the question asks, given that these things are all equivalent, right? 2 moles of butane is equivalent to 13 moles of oxygen, etc. Just like that. Let's solve a problem. How many moles of carbon dioxide? That's right here. Will be produced from 1 mole of butane, given plenty of oxygen. Since there's plenty of oxygen, we can ignore that. That simply means it doesn't limit the reaction. And we want to know how many moles it can make. Here's doing it in your head, which is all we really need to do. Every 2 of these will make 4 of those, 8 of those. Every 1 of those will make 4 of those. So all we got to do is quadruple it. The answer is 4. 2 makes 8, so 1 must make 4. Here's another problem. How many moles of oxygen are needed to react with 17.26 moles of butane? So there's your moles of butane. They're asking about oxygen. How much do you need in terms of moles to moles? Well, these are mole ratios right there. Every 2 requires 13, 6.5 times as much. So if we simply multiply that by 6.5, we'll get the answer. I recommend you write it as a unit conversion, however. Start with what you're given, your 17.26 moles of butane. Convert it, recognizing that every 2 moles of butane requires 13 moles of oxygen. Notice that that mathematically cancels your units and gives you what you want, which is the moles of oxygen required, which is a little over 112. Looks like we're paying very little attention to significant figures here. By the way, for AP Chemistry, generally speaking, the golden rule is to use 3 significant figures. This seems to apply to most, if not all, AP Chemistry questions. How many moles of butane react with 0.42 moles of oxygen? Well, let's start with what we're given, 0.42 moles of oxygen, right? And we want to know how many moles of butane are required to react with it. Well, it's a little less than a sixth, right? 1 over 6.5. And so we can go ahead and do that. Every 13 of those only required 2 of those, so it's multiplying it by 2/13. And when you do that, we should get a much smaller number. We only needed 0.065 moles of oxygen. Okay, 2-step problems. Mole to gram conversions. Memorize that mole to mole conversions are 1 step, mole to gram are 2 steps, and gram to gram are 3 steps. There's alternate ways to do this, which AP Chemistry students should be aware of and could be time savers. Mole to mole, for example, can be no steps at all. Do it in your head. Mole to gram, potentially do it in your head. And the other ones you can either do by this standard method, or you may like other methods such as writing out a balanced chemical equation and using a sort of lab notebook method to see what the ratios are and then just running it through. That can be particularly useful for limiting reactant problems, which are not on this slide. Okay, so start with what you're given, 3 moles of butane. Right? Recognize that it's a 2-step process. Mole to gram are always 2-step process. And then work our way through. If we have moles of butane on the top, we must have it on the bottom as well, so that otherwise it doesn't convert. And a mole of butane is equivalent to how many moles of carbon dioxide? 2 gives you 8. Of course, you could write 1 and 4 if you preferred. And then we want to know what its mass is. Well, the mass of a mole of carbon dioxide, notice we always make sure our units cancel. Moles of butane, moles of carbon dioxide, it's gone. And a mole of carbon dioxide is equivalent to 44 grams of carbon dioxide. Where did that come from? 12 for the carbon, 32 for the pair of oxygens, totaling up 44. Punch it in. Cancel your units. 528 grams of carbon dioxide. Here's another one. Combustion of 4 moles of butane will require how many grams of oxygen? Well, by now you should be recognizing the pattern. It's a 2-step conversion. Start with what you're given. We're given 4 moles of butane. It's a 2-step conversion. It's all set up. A mole of butane, notice that we automatically can write that on the bottom since we're going to convert from moles of butane to wherever we're going. Where are we going? Oxygen. 2 moles of butane requires 13 moles of oxygen. What does it weigh? Well, a mole of oxygen weighs 32 grams. Punch it in. We need 832 grams of oxygen. Notice the utility inherent in these processes. They tell you how much you would actually have to weigh out. That's something a chemist would need to do if he's in the lab. That's something a chef would need to do if he's cooking and wants to use the right amounts. That's something a doctor would need to know if he's prescribing the medicine. So this is the kind of thing that really is practical stuff. Okay, this is screencast 2.4, mol to mol and mol to gram conversions.